Hi, my name is David Nelson, and this is my RP project on a school navigation application. To tell you a little bit about my project, it can be a little challenging for high school freshmen or transfer students to find their classes throughout their first year in the new building. This is an issue that continues year by year and causes unnecessary stress on students before they even get to their classes. The purpose of my study was to develop a mobile application that will help students locate their classes and overall help them maneuver the building in a simpler manner. The mobile application was developed using an integrated development environment known as Xcode, which is provided by Apple's Mac devices in order to create iOS compatible applications. There are two methods of testing the product during and after development. One is a simulator provided by Xcode that mimics the app's functionality and appearance, which I'll show you a little bit later. The other one is connecting your Mac device to a compatible iOS device and downloading the app onto your phone that way. In theory, this product will enhance the learning experience and ease the transition for students to their new schools. As I stated before, the purpose of this study is to develop a mobile application that will assist students in locating their classes and simplify their overall navigation of Oxon Hill. These are the materials that I used in the application development: a 13-inch MacBook, the Xcode integrated development environment, an iPhone 12 Pro Max to test the device or the application, the Mac OS preview application, which was used in making the map views, and the Oxon Hill High School building plan, which was used as a reference. In order to do that, you start by opening the App Store, entering Xcode in the search bar, and clicking the Install button next to the Xcode application. The next step was creating a new project. After launching the Xcode app, you would select Create a new Xcode project, select iOS and Application. Using the text box and drop-down menus, you can configure the options for the project to fit your needs. Lastly, you'll select the storage place for the project files and click Create. Next comes the development of the application. I use the Swift programming language in the Xcode editor to code the application. I use the user interface, Swift UI, to create the user interface for the application. And using the utility area, I was able to configure the elements of the application. Lastly came the testing and debugging process. I used a compatible iOS device and connected to the Mac that I was using to develop the application. On the iOS device, I selected yes when I was prompted to respond to whether or not I would trust the Mac device. On the Mac device, I also clicked the play button in the top right corner in order to run the application on the connected device. After the application ran on the device, I could use it just as it was any other app in the App Store and maneuver through it to test any errors. On the Mac or MacBook within the Project Navigator, I can see issues indicated by a caution sign. I could also use that tool to analyze and fix any issues running in the application. Next, I'll be showing some of the data that I collected during the development process. Here are some of the views that I wrote the code to load in and to display background colors. So here you can see I installed the background color white, and these are just loading in the rest of the views. Here are more views that were loaded in the view controller. Here is the first map that I made in Google Drawings to mimic the map of the school building. Here's the second floor of the school building, and here's the third floor. Here are the list of assets that I used in order to be used in the image showing in the app. So when you click certain links, as I'll show, or click certain buttons, as I'll show later, they'll take you to see different views, and these are where these different views are stored. Next is the home screen and selection views. This is basically the startup screen that you'll see once you open the app. And after selecting start, you will see this view here, which will allow you to select to look at the other maps and pathways. Next is the full map views, which will be activated by pressing one of these top three buttons. And they each correspond to one of these views, so for the first, second, and third floor. Next is the sample schedule views, which will be activated by pressing one of the bottom selection of buttons, and each one corresponds to one set of views. So for the analysis of the data, instead of Swift files, the majority of the project's development was converted into storyboards because the visual response that you get from storyboard as you continue to edit it, it allowed for a more efficient programming process. It also organized the attributes in a more user-friendly and aesthetically pleasing manner. The most recurring syntax error was concerning the segues between view controllers, which are basically the transitions. After analyzing the issue, two main problems were found. There were inconsistencies in the naming of the views, buttons, and elements, and the use of the names in the view controller Swift file. The images and assets used in the view controllers were not constrained properly. After analyzing and going through these issues and perfecting them or correcting them, the process was made a lot simpler, and there were a lot of repetitive things that had to be done. So once we got past that issue, we was able to move along a lot quicker. Now, although this application works properly, there are an abundance of advancements and innovations that could be made in the future. For example, a future researcher or programmer could create an entire system of QR codes that help the student navigate from their current location rather than entering their location themselves. This can make it easier for students who have trouble identifying where they are in the building based on their surroundings. Another advancement could be utilizing three-dimensional CAD software to create map systems. This can make the school's appearance more recognizable to new students. Lastly, a programmer could transfer the application to a GPS-style application that tracks the user's movements. This would be the most advanced version of this application and would require the most knowledge and expertise. Taking the aforementioned actions would create a more immersive experience for the user and likely improve the public response upon the application's release. Now, lastly, I just want to go to the simulator and show how the application works. So here's the home screen where the start button is. After selecting start, you'll be presented with this list of maps to select from. So here are the full maps, and this is a sample schedule. So here's the first floor map that you can scroll across to see the full view. Same with the second floor. You can scroll back and forth. And then with the third floor, the same. And then the sample schedules all show a red circle to indicate where the user is, and then a green arrow to show what path the user should take. Most of these are pretty similar, but if you scroll down here, you'll see that this view shows two because you're going from floor to floor. So here, you start from the cafeteria, head this way, go up the stairs, which is indicated by the stairs being highlighted, and then here it continues down here once you get to the second floor. And there's one more view that contains three because you're starting from the third floor going down to the first floor. So here it shows where you are on the third floor, take the stairs, go across here to the rotunda stairs, and then you're finishing by going to the gymnasium by walking through the hallways. And that will conclude my presentation. So thank you for listening and have a great day.